Hi, my name is Anka Horvath. I'm a postdoctoral researcher with the Research Laboratory for Art and Technology in Aalborg University in Denmark.
It's Viola Ruhse. I work at the Department for Image Science at Danube University Krems in Austria as a research assistant and course director.
Our paper is called Chladni Patterns on 3D, and it is a review study on ways to use invisible sound information to create physical three-dimensional form, and more specifically on how this was done in works of architecture, design, and fashion. We described methods for producing Chladni patterns, processing them into 3D geometries, and the conversion from the 2D images to the 3D digital visualizations and fabricated objects. And this topic belongs to the realm of cymatics, which means the visualization of sound wave patterns. This investigation started because both of us found images like this seducing. Viola's background is art history, and she works more specifically with image science. And my own background is architecture, and my interest was to understand how Chladni patterns or cymatic experiments can be materialized into physical objects. Although we found several studies presented separate works, we didn't find a comprehensive analysis of cymatics, Chladni patterns, and how to process them into 3D objects. The research question which guided our work is what methods have been developed to transform sound, and more specifically sound derived from Chladni patterns, into 3D geometries and fabricated objects, and what visual languages have these produced in objects of architecture or design.
At first, we will present a brief overview of the history of Chladni patterns. Special consideration will be given to experiments in the 1960s that allowed more 3D-looking images of sound. In the second part, methods, tools, and algorithms used to make the transition from 2D images to 3D models will be analyzed. In addition, post-processing and fabrication methods and materials used for the fabrication will be examined. At the end, applications of 3D Chladni patterns in architecture, design, and fashion will be presented. One significant characteristic of sound is its transientness. Hence, there have been several visualization attempts in the past. These visualizations are connected to the research of sound waves that has a longer history. Its first beginnings can be dated back to the Renaissance. For instance, Leonardo mentioned in his notebook that when a table is struck in different places, the dust that is upon it is reduced to various shapes of mounds and tiny hillocks. Afterwards, Galileo Galilei described in dialogues concerning two new sciences marks on a brass plate caused by a whistling sound due to a sharp iron chisel being scraped across it. The English scientist Robert Haack observed nodal patterns in association with the vibrations of a glass plate with flower caused by a violin bow in 1680. Ernst Chladni repeated and developed Haack's experiment further. Chladni scattered sand over a thin metal plate. Striking a violin bow against the plate sets it in vibration, and the sand grain formed a special pattern. Chladni perfected his method and was able to create different patterns published in his famous book, The Acoustics in 1802. His public demonstration of the experiment became very popular and were admired by contemporaries such as Goethe. The German Romantics were also interested in them. The phenomenon of the Chladni patterns was researched by other mathematicians and physicists. French astronomer Camille Flammarion integrated Chladni's experiment in a popular science book and interpreted the patterns as evidence of cosmic harmony. There were also successors of Chladni who took up his approach and extended it with other aspects. Since the 1960s, new devices have been used in the experiment setup. For instance, Hans Jenny took up Chladni's experiments and expanded them. He no longer used a violin bow to generate the vibrations, but very precise electronic tools such as frequency and vibration generators, as well as piezoelectric amplifiers. He also used different materials like quartz, sand, and powders, and he made several membranes and liquids vibrate. Liquids react more vigorously than solids. For instance, water responds to sounds with wave patterns that often have flower-like forms. The water experiments by Hans Jenny and his followers since the 1960s included the depth effect that the former illustrations and photos of Chladni experiments on the plate were missing. Thus, the newer experiments looked more three-dimensional. A wider spectrum of frequencies could be also made visible. Cymatics is often connected to esoteric beliefs. For instance, Hans Jenny was influenced by Rudolf Steiner's anthroposophy. In Jenny's view, all forms in the universe are caused by an invisible vibrational force. Jenny published his experiments and thoughts in a book containing 2 volumes, titled with the self-coined word cymatics. Jenny gained a lot of attention. The aesthetics of his experiments suited his times with new art genres like op art, and his ideas were in line with New Age movement. In the 21st century, the Chladni experiment seems to become even more popular due to the many videos posted on social media. In addition, 3D visualizations of the Chladni experiment have been possible because of technological advances in computational design. They have also become more frequent and are now presented in research articles.
Now, looking at more contemporary works, and in order to understand how Chladni patterns can be used to inform 3D shapes and finally fabricated objects, we analyzed 3 different methodologies or workflows. The first one is based on the mathematical formulation of 2D Chladni patterns and translated into 3D. The second is a software application where Chladni-inspired images were processed into a CNC milled sculptural piece made from wood. And finally, a third workflow presented a method which resulted into a 3D printed object, also inspired or informed by Chladni patterns. So the first workflow uses the mathematical formulation developed originally by Chladni and then translated into 3D and coded in MATLAB. Then different parameter combinations are given. The results are rendered with different degrees of grid fineness, but as you see, this workflow does not create physical objects, so the 3D models would need further processing if they were to be fabricated. A second workflow created a small software application called Cymatify. This is also based on Chladni's formulation, and the equation is coded using processing. Cymatify lets users interact with parameters such as frequency, grid size, and pattern density, and allows the export of 2D images. The authors then describe how they imported one of these 2D images into the neural modeling software Rhino 3D, and how they created a point cloud. By using the visual programming language Grasshopper, the z-value of the points are modified based on pixel color data, and finally, a shape is exported for CNC fabrication in a wood material. Another workflow used to develop 3D printed pieces describes creating patterns from sounds using a script application which sends specific sound combination to vibrate a physical Chladni setup. The authors then took pictures of the created patterns, imported them in Rhino 3D again, where they stacked the images on the z-axis. Similar to the previous project, point clouds were created and the z-values of the points were changed according to pixel information from the images. Finally, an isosurfacing algorithm was used to extract a mesh from the point cloud, and this mesh was later 3D printed. If we extrapolate from the 3 workflows that we've seen so far, we can see that there are 3 methods for creating Chladni patterns. The first method is working in an analog way. A second method is mixing analog and digital. And the third one is by creating the sounds and keeping everything digitally in the computer. Creating Chladni patterns in an analog way is basically done using setups similar to what Chladni used originally, and the sound frequencies are made by vibrating plates on which a granular material such as sand or salt is scattered. So because not all sounds will create clean Chladni patterns, mixed methods were used, similar to what Hans Jenny was doing in the 60s, where physical sounds are computationally modified and then sent to vibrate a Chladni plate. Finally, Chladni patterns can be produced entirely digitally based on Chladni's mathematical formulation. So what are the options for somebody who wanted to create Chladni patterns sound-informed 3D geometries? On the one hand, there is the possibility of working with the mathematical equations directly and then feeding parameter values to this equation and render 3D objects. In this case, the 3D models need to be prepared for fabrication further by giving thickness to the mesh and minding the phase normals. On the other hand, there is the option of working with pictures and creating point clouds from these pictures. The Z dimension of each point can be modified according to color information, and finally, from this point cloud, surfaces can be extracted by isosurfacing, which is also a method used in the medical field for processing data from MRI or CT scans. And then different fabrication methods can be used to produce such 2D models. They can either be done manually, as we will see in some examples in the following slides. On the other hand, the shapes can be sliced and be laser cut and glued back together. We already saw an example which presented a CNC piece and also a 3D printed piece.
For artists, architects, and designers, Chladni patterns are inspiring because their special and organic forms are visually appealing. Chladni patterns in 2D are used in design, for instance, for the decoration of mugs, fashion, and carpets. They also inspire artworks, photographs, and paintings, but also elaborate multimedia artworks. In the music realm, Chladni visualizations are more frequently applied. They are used for music videos and stage visuals, for instance, by Björk. There have been also attempts to market them as music software. 3D Chladni visualizations have been used in apps for school education and for the interested public, but there have not been so many applications beyond that. Their potential to create new and special forms and spaces still needs to be discovered more. In the following part, a few selected 3D applications will be presented. John McGowan created innovative 3D cymatic visualizations accompanied by music. They are based on images of Chladni patterns in water for different pitches. McGowan processed these images with a 3D modeling software and used several visual effects techniques for modeling the 3D Chladni images. For instance, he added rotations and motion blurs. He also applied a special soap bubble material for a translucent layer. All layers were assembled with new compositing software at the end. McGowan's short film interprets in an extraordinary way how music travels through the air.
In architecture, digital music visualizations have inspired postmodern projects such as the temporary Pavilion 21 mini opera space by Coop Himmelblau, which was built in 2010. The shape of the pavilion was created by taking Jimi Hendrix's Purple Haze and a passage from Mozart's Don Giovanni and transformed those into some architectural elements. In another example, 3D Chladni forms were taken up in a conceptual project by the American architect Shi Michael Trahan. He designed a utopian-looking Temple of Sound concert hall. Trahan used the software Tonoscope developed by Kevin Dill and Sergei Mikhailov for the 2D images, and he reports developing algorithms for transforming the 2D images into 3D models, which he, however, does not detail. Trahan says he paid special attention to the effect of the 3D modeling on the acoustics and declares the Temple of Sound as a decidedly experimental project. Potential use for the design of architectural spaces would include, according to Trahan, sensory laboratories, sonic therapy chambers, or theaters, amongst others, but he says the clients would need to be able to finance such a project. In 2013, Dutch designer Ricky van Broekhoven created the sound-shaped speaker. He made a series of experiments with Chladni plates. He recorded these experiments and then he took pictures of them. And then based on these images, he had 16 MDF layers, hand-cut, bonded, and covered with polyurethane for the casing of the speaker. He explained that the end does not only look special and attractive for high-end customers, but sounds better than other loudspeakers. And of course, it seems very appropriate that sound visualizations are used for the design of objects that produce sound from electrical signals. Dutch fashion designer Iris van Herpen was more freely inspired by Chladni visualizations in her haute couture autumn-winter collection in 2016, which she called Seijaku. For instance, the ultralight amaike organza of one short dress was shaped and hand-stitched on black cotton with the traditional Japanese 3D shibori technique. and this ornament is inspired by recurring honeycomb Chladni patterns. This honeycomb ornament on the dress, which has like a 3D effect, is similar to Hans Jenny's Chladni experiments with waters. There is also a counterpart to the snail shape in the lower part of the dress in Jenny's experiments, because Jenny documented vortices in liquids which were caused by vibration. Iris von Herpen's use of the ultralight thread for the sound patterns expresses the floating characters of sound waves in a tangible way. In addition, the dress makes visible how sound unfolds in space and how it not only surrounds the body but also lets it vibrate. The special sculptural 3D shape of Van Herpen's dress enhances the creative character of her fashion style and underpins the artistic claim of her fashion creations. The organic Chladni forms act together with the traditional methods as an interesting counterbalance to the technological high-end materials such as the thinnest organza in the world.
We hope that our explanations on 3D Chladni patterns will be inspiring for you too.